This was exactly the same slide which I showed you. And the trade-off between the choice of the materials and technologies and their effect on the environment has to be balanced with the aim of closed loop system. And we also discussed several important definitions, terminologies, and I intentionally left 2 or 3 important definitions and terminologies like embodied energy, embodied carbon, life cycle analysis, which we will take up in this session now. But before we actually get on to the actual definitions and then this thing, I would like to see what exactly is the objective of environmental management plan, which we call it as EMP. To prevent or mitigate the damage to the environment due to the project by adopting best environmental management policies and practices specified in the contract and legislations gazetted by the Government of India. Environmental management plan is a tool to implement environmental safeguard measures. EMP, that is, I'll call it as EMP now, is derived from the outcome of the environmental impact assessment, which we are yet to see. So it is entirely based on the environmental impact we assess. And Section 202 of the Environmental Protection Act states that the purpose of EMP is to propose environmental protection commitments to assist the administering authority to prepare the final policy. So which means to say that incorporating and integrating the environmental management plan in our EPC becomes very, very critical in future. Now, there was in the last session, there was also a question as to why exactly so much of focus only on buildings and why not on some of the infrastructure projects. So, dear friends, actually, this is the answer here. Now, for example, your domestic, commercial, and industrial energy consumption put together, it comes to about 73%, as you can see it in the P chart. And that is why the focus is on the buildings, which is actually concentrated more so in urban scenario. When we take up a national, infrastructure projects, majority of it, they're exclusive projects where their function and then service is looked into, and they actually do not come under this purview of exact sustainability aspect of it, in the sense that the damage they create to the environment. Am I audible, Rangna?
Yes, yes.
Rangna, kindly mute.
Mute again.
So,
yeah.
So, dear friends, so this is why we focus more on the buildings. Roads, for example, one of the important factors that affects the road or the environment through the road project is actually the habitat fragmentation, what we call when it separates two habitats residing on two different parts of the road, then they create a lot of confusion, especially in the animal species. So one of the important factors is that habitat fragmentation, and then it's altogether a different scenario as far as the sustainability assessment of infrastructure projects, and that too in the roads and bridges. Other infrastructure projects can covered under buildings itself. For example, power stations, atomic reactors, all these things can actually be considered and then assessed and analyzed based on this one, the present condition. Now, another important reason is natural resources are currently being consumed at the two times the rate they are produced. And by 2050, this could be actually 3 times. Growth in the world's middle class population is estimated to expand almost from 2 to 5 billion by 2030 itself, adding to the existing demand for homes and services. And this puts a lot of pressure in the urban scenario, and hence the focus is on building industry and then building area segments. Now, let us go to the next slide. Now, what exactly is embodied energy? Now, embodied energy is the total non-renewable energy that goes into the manufacture of a material from its extraction till it is consumed. It plays a very important and critical role in the choice of building materials. Now, this embodied energy gets classified into initial embodied energy, recurring embodied energy, and then end of life energy. Initial embodied energy actually is the energy consumed in the entire process from the acquisition of raw materials to the construction of the building. Now, let us, for example, take ceramic tile, which is a very common flooring material which used very commonly. What does it take for preparing the ceramic tiles to come to us and get used into the construction? Now, it requires to make a ceramic tiles, we need the raw material, we need the processing of raw material, then we need to manufacture, it undergoes manufacturing process, then it gets packed, it gets delivered to the site. Now, the entire energy consumed in this process, maybe it is a fuel energy or the electricity, the power which is generated by either the clean energy processes or by burning of fossil fuel, anything can happen. All that energy included together till the product comes to your site and then gets implemented, gets consumed, that is the initial embodied energy. Now, the recurring embodied energy is the energy consumed to maintain the repair, restore, and refurbish or replace the material components. And end-of-life energy is related to the disposal or recycling of a building. Now, all these three energies, initial embodied energy, recurring embodied energy, end-of-life energy put together is the total energy footprint of the particular building. Embodied energy is always expressed in terms of joules per kg or megajoules per kg, or it can also be expressed for any unit. It can be megajoules per square meter, it can be megajoules per cubic meter. But when we take the product, then it is usually converted into kgs, its density, and then megajoules per kg is the unit actually used for expressing embodied energy. Now, what I hope I don't have to remember what exactly is joule. I'm sure all of us remember and recollect. Anyway, the joule is the SI unit for work or energy, which is equivalent to the work done by a force of 1 Newton to move the object by 1 meter in the direction of the force applied to it. Now, this is embodied energy. Now, what exactly is embodied carbon? Yeah, embodied carbon is the carbon footprint of a material. It considers how many greenhouse gases or what is the quantum of greenhouse gas that is released through the supply chain. Now, carbon dioxide is significant as explained in the first class. Carbon dioxide is one of the most significant gases among the greenhouse gases, and it is often simply referred as carbon emissions. Now, this embodied carbon is always expressed in terms of kg CO2 equivalent. That is because while taking all the other equivalent the greenhouse gases into consideration, and we also talked about global warming potential in the last class, and that is why everything is converted and expressed in terms of kg CO2 E per kg. Now, it is estimated that about 0.09 tons of carbon dioxide is produced per gigajoules of embodied energy. Now, here I take a pause. Now, we know that what is embodied energy and then what is carbon, embodied carbon. And now let us look at what exactly is the life cycle analysis. A life cycle analysis is acronym normally as LCA. And this life cycle analysis in buildings, it can be applied to a product, it can be applied to several other things. But when a life cycle analysis is applied to buildings, it can be defined as a method of assessing the sustainability levels of buildings, infrastructure projects from pre-construction phase to demolition phase, satisfying cradle to grave principle. So we also talked about the four principles: cradle to site, cradle to gate, then cradle to grave, and then cradle to cradle. So once we understand this entire, very general, there are quite a few methods adopted in analyzing the life cycle, doing the life cycle analysis of buildings. But some of the three of the common LCA methods are process analysis, input-output analysis method, and the hybrid analysis. Now, in the process analysis of LCA, what involves the data related to each of the processes starting from raw material extraction is taken into consideration and applied. Now, what happens is we really don't know. This non-availability of reliable and admissible data is actually one of the biggest problems, not only in India, but any part of the world. It's extremely difficult to exactly monitor and get the admissible data, what exactly happens for each event, and then for every utilization of, whether be it extraction of the this thing, whether it is extraction, whether the equipment that is doing, how efficient is that, all these things actually come into the picture. Then same thing when in input output analysis, it captures and derives data from several sources, including the data from economic sectors, and hence it has got its own limitation. Now there is the third method, which actually incorporates or integrates the process analysis method and the output analysis method, which we call it as hybrid analysis. And then this takes into the advantages of both the analysis, both the methods of analysis. Now, this is how we actually go into, because this hybrid analysis also allows us interpretation of and derivation of a lot of data that can be by way of experience which has been accumulated. Now, just an example, what I would like to do is I would like to show you a small case study where we can assess the building even with the minimal data that is available to us. How even with little amount of available data, how can we actually assess this? What is important in this analysis or in this type of this thing is how accurate is your data. The higher the accuracy of the available data, higher will be the accuracy, the closure will be the understanding of the building. Now, I would take the example, I hope you can all recognize this, Antilia, Mumbai, one of the world's most expensive home. Yes, that is of Ambani, Mukesh Ambani, and this is the screenshot of Almount Road, Mumbai, and you can see the helipad, and that is Ambani's residence. Now, what is the detail that is available to us? You can see that this is one of the costliest places, and almost all buildings in and around this particular building are high-rise buildings. And when we take this into consideration, and we all know that first of all, it is one of the world's most expensive home as per the Forbes interpretation. And dear friends, it would be extremely wrong on our part to apply, to derive at the analyze such kinds of buildings and then normalize them or bring it to the common strata. It is not possible. I think we will have to eliminate these kinds of buildings. For example, Burj Khalifa. All these things become actually called as iconic structures, and they are never built with an idea to be a sustainable building or something else. They just want that building to be the tallest in the world, period. So this calls for, these are iconic structures which cannot be actually understood. But out of curiosity, out of academic interest, I did this exercise and then just placing it before you. In the plot, request the participants to kindly mute their audio. Hearing a lot of news, sound from the, yep, thank you. The plot size is almost about an acre. Total height of the building is about 173 meters. Number of floors, 27. Average floor height is about 6.5 meters. Area of construction, 4 lakh square feet. Each floor plate is about 15,000 square feet. Cost of the land on that is about 1.25 lakh per square foot. The total cost of construction as estimated is about 13,000 crores of rupees. Type of construction, a typical RCC framed, obviously extremely complicated structure with 3 meters deep raft foundation. And this is the only data which is available. In addition to this, this building holds about 6 floors of car parking for about 168 cars of Ambani's, and then 50-seater theater, swimming pool and spa, artificial snowfall room, helipad, and ATC floor, etc. All these things get encompassed. Now, what is important to see here is, it is almost every floor is a double height, double ceiling anticipation. 173 meters, we normally go up to 58, 50, 60 number of floors, but here it is almost about 27 floors. Now, what do we get from this? What kind of analysis can we draw from this? Now, look at this particular thing. Now, we have understood that after accommodating for the cost of the land, etc., and the consultancy fees and all those things, approximate cost of construction could be about 11,500 crores. Now, when we divide this, and cost of construction per square meter works out to be about 2.86 lakh per square foot. Now, let us leave this cost aspect of it little aside, because in this particular analysis, this cost stimulants do not come into the picture. Though it is an extremely important factor, when we analyze the buildings using embodied energy perspective or embodied carbon perspective, the cost stimulants of the real estate, they do not come into the picture. That is why United Nations Environmental Program insists for locally developed sustainability development indices, which we will come to it later. Only from the embodied energy perspective, now look at this. Now, all over the world, there is for extremely opulent residential buildings, RCC buildings, the embodied energy actually ranges from 9,000 to 15,000 megajoules per square meter. So I have taken the least component here. Even if taking about 9 gigajoules per square meter, and the total entire embodied energy impact comes to about 336,510 gigajoules, which approximately is about 33.65 crores megajoules. Now, when you convert this into the number of units, each, we have 3.64 megajoules making 1 kilowatt hours, which is actually 1 unit of electricity what we use. So number of units consumed is about 9 crores 24 lakhs 47,802, which at the rate of about 10 rupees, which is applicable for the commercial rate, this building has consumed about 92 and a half crores of electricity during its entire construction period. Now, the total, each ton of the total embodied carbon, and assuming that we know that from the thumb rule that about 0.098 tons of carbon dioxide is produced per gigajoule of energy. So when we apply this, the total embodied carbon or the greenhouse gas emitted by this one building is about 32,978 tons, which actually means that this building, one building has estimated, has emitted about 33,000 tons of carbon dioxide, occupying almost about 2 crores cubic meters of atmosphere, which is approximately comes to about 265 meters by 265 meters by 265 meters of space. And it is equivalent to burning 11,556 tons of coal and consumes about 10 lakh liters of water. And most of it is the potable water. Even we assume that there is some treated water which has taken into consideration. Normally it is taken as 80% of the water is potable water. This is on the assumption that on any typology of a building, the average water consumption during the construction phase, the average construction consumption of water is about 20 to 27 liters. So this actually is a very approximate analysis of one building based on the data that is just available. Now, this I just showed it to you. So when actually this can be applied, one building, participants, can you please mute your audio?
I'll take care of it, Ajit.
Yeah. So because it breaks my complete flow and then a lot of disturbance. So once this comes into the picture, so this is one building, and if similar exercise is done for the cluster of buildings in that area, we actually know what actually is the damage the entire built environment is creating. Now, anyway, we will go to the next part of the analysis. Now, what is required is the sustainability assessment and then sustainability design actually calls for establishing what are called as baselines. So this we call it as establishing a benchmark. Like we have a benchmark in surveying, which becomes the referral point. Now we have the values of benchmark building, and this is the establishing establishing baselines for the further assessment and further comparison. United Nations Environmental Program actually from time to time they do indicate what exactly could be the benchmarks, or depending also gives the flexibility to choose to the engineer or at the discretion of the designer to choose his own benchmark project. Which means to say that because taking the climatic conditions into consideration and the local environment into consideration, the availability of the local materials, the entirely localized parameters and the environment taking those things into consideration, a designer has got a flexibility to evolve his own benchmark project or the benchmark baselines. Now, in this particular figure, the comparison helps improvements in the overall energy performance of a building under assessment, and real energy performance values as compared to baseline values provide an indication of sustainability level of a building in terms of, in relative terms, you can say. Now, then also benchmarking of buildings provide a set of measurable baseline values that can be compared with the real-time energy performance values and of a building to be assessed. These are the two buildings which I have involved, and then just put just for the break of the monotony otherwise it becomes extremely monotonous. So the right corner, what this particular building, what the red earth, what you see actually is complete the earthen concrete road. It is not an RCC road. It is completely a earthen concrete road which has been taken care of. Now, this once we establish the benchmark, what is important is it also has to be actually evaluated by set of certification programs that can happen. For example, any benchmark project, let us say we decide upon, and then it can be right now with the available green building ratings, whether the building what you have chosen, does it fit into the bracket, or is it right or is it wrong? That evaluation of the benchmark project has to be done in comparison with the already existing procedures. Now, for example, the one building which I had taken, now that we compared it with LEED certification credits. Now, LEED certification credit has got maximum 110 points, and the benchmark project what we take earned about 101 points, which means to say that it falls into the platinum category. And these, we do not have numbers, but these are only all, as I've been repeatedly saying, all green rating systems, or at least the most of the green rating systems, are criteria based. So however, they actually point, and then they take us to go through to make our journey through the sustainability quite in the proper direction, and then they put us in the right track. So that is how these things are extremely helpful. So cross-checking with established criteria can help. Now, similarly, comparing the benchmark project with reference to the IGBC Green Home certification, and out of 75, it has acquired about 71, which again falls into the platinum category. Then when we compare that into one of the buildings, what we are going to discuss subsequently, we can compare actually a benchmark project, if that becomes the referral point, if it can be taken as 100%. So any of the, how far is the demonstration project or the project what we take into consideration? For example, the project what we took into consideration, the Antilia, actually comes to about 26% against 100% as against the benchmark project which we have taken. These are just an indication, and just to tell you very indirectly how to go about it. So the benchmark project has to be evaluated and with reference to other criteria also. Now, we just for the sake of this thing, there are green building ratings, almost quite a few. There are almost about 64, 65 well-known green building rating systems. And suppose we take out of which BREEAM, then CASB of Japan, LEEDs of USA, Indian Green Buildings of IGBC, and GRIHA of India, HK Beam of Hong Kong, BREEAM of UK, Green Mark of Singapore. All these are actually quite well-known green marking rating systems. What exactly are the green marking systems, and then why we base only on criteria-based markings? We will just look at this. I've taken the IGBC rating criteria for homes, for home buildings. Now, these are the criteria. For example, local building regulations is required. That means it is mandatory. Without local building regulations, your building cannot be even rated also. Then soil erosion control is mandatory. Then there are about 11 points as far as the site conditions are concerned. As we can see it, that there is a topography and vegetation is concerned, and then heat island effect is concerned, roof insulation, all these different parameters are concerned. So totally about 11 marks for sustainable sites. So water efficiency, then we have rainwater harvesting, water efficient plumbing fixtures, whether you have adopted landscaping, whether you have management of irrigation system, rainwater harvesting, water efficient plumbing fixtures, all these things like this. These are different criteria which we actually adopt them, and then arrive at some kind of a rating system, whether the building is X rated, Y rated. And once we understand these ratings, we try to adopt the mitigation strategies. How can we go further? Now let us look forward. This is again a continuation of what exactly is the material resources. Now, what we see in these things is, if you don't carry out certain criteria, so you don't lose those marks, isn't it? So what is important is, now this cannot be, there is a possibility that we can do this at the conceptual stage or the design stage, but all the stakeholders involved are going to be involved, have to be come together, and then they should take part. And one of the important sustainability design aspects is actually to be very frank with you, the structural analysis algorithms do not change at all. What actually changes are the materials. What actually changes are the properties of the materials what you use. the structural analysis part of it, it remains the same. So the loading pattern may change, loading may come down. All the other analysis, while other things remain same, what actually changes has to change, probably I would put it that way, is the mind shift from linear to circular construction. We already decided in the last talk what exactly is the linear construction and what actually is the circular construction. Now, in the linear model, the feedback by the suppliers into the early designs, there is no feedback at all. Now, site planning and design and approvals are done without suppliers or building contractor. Contractor is selected at a later date. Contractor selects the suppliers based on the approval of the suppliers, and if there is a list of approved vendors given by the client or the is taken into consideration, and the end result is what suppliers and constructors are normally not included in the overall design process at all. And they not communicate with each other on the systems integration. This is one of the biggest drawbacks of the linear model. Now, the circular model actually calls for entire transparency in the entire process, where everybody should be involved right from the beginning. Now, the starting point here in the circular thing is includes even the potential suppliers and the constructors. Planning and designing include consultation with the potential suppliers and user. Transparency between all the stakeholders has to be maintained. Suppliers complete on the basis of the highest quality are known and what price he is getting. And the end results is what? Transparency in products, supply, systems integration and pricing, and improved quality and lower failure and rates add value. So all these things are actually known. Tremendous amount of transparency is called for, and that is why more than anything else, there is a mind shift which is required at this stage when we actually adopt a true sustainability in true sense. Now, we have what is called resolve. To begin with, this particular framework actually helps us to illustrate how their circular economy actually can be applied to sustainable design. This resolve stands for regenerate, share, optimize, loop, virtualize, exchange, etc. And then regenerate is actually taking shift from our renewable energy and materials, reclaim. All these things actually what we have written, they come into the picture, and this is one of the important aspects which we have to take while we apply from cradle to cradle basis. Now, this is another example of a building of a low energy building. It's one of the community dining halls where I was involved with. The embodied energy is about 3,600 megajoules per square meter, and embodied carbon is about 370 kilograms CO2 kg. It's a regular RCC frame, concrete louvers, where we can see these concrete louvers completely integrated, seamless integration with the outside nature, natural stones for the flooring. And this is a typical sustainable building, low energy building, which we were dealing with. Now, let us go, how do we peg the preliminary environmental performances? Now, once we go ahead, let us begin with what exactly is step one and what exactly are the different parameters we need to consider. Now, the first and foremost important thing is actually to peg the preliminary environmental performance targets. Now, we have what are those preliminary targets? The energy, the water, materials, economic performance, landscape, indoor environmental quality, waste, and construction practices. When it comes to energy, we can think of doing anything, what kind of energy is used, what is the source of energy, whether it is a clean energy option, what kind of transport do you use, etc. When it comes to water, what kind of water do we use? Is it a treated water, or what kind of harvesting are we into doing, and what is the way we are trying to conserve the water? All these things can take. When it comes to materials, whether it is recycled materials, salvaged materials, locally available materials, such kind of things. When it comes to economic performances, the life cycle assessment, as we already discussed, has to be done. And landscaping, we need to understand whether what will be the ratio of the softscape, what will be the percentage of hardscape without affecting the microclimate, which we also discussed in the first session. Now, the indoor environmental quality, what is the kind of air pollution, and what kind of indoor ventilation effectiveness, what is the air filtration, what system commissioning for cleaning, what is the daylighting. All these things have to will come into the picture as far as the indoor environmental quality is construction. And waste, whether it is going to be recycled, and whether are there any composite composting facilities, everything. And then what kind of disposal strategy is adopted. Construction practices, good construction practices, how do we treat the waste, how do we reuse, whether the topsoil, are we using the topsoil again, what do we do for the vegetation, are there some exclusive species, etc. All these things have to be looked into consideration. This is the green building guidelines. Also, checklists of rating systems can be used to set these targets. And important thing is, we need to, while selecting the sites itself, we need to avoid the designated forest lands, flood land, ecologically sensitive land, habitat and endangered species, whether it is wildlife species are there, wetland, etc. All these things have to be cancelled or considered. The second step is actually protect or enhance sites' ecological integrity, which comes into the picture. Now, we have to minimize the development footprint. This includes parking, building of roads, cluster of buildings coming together, then locate the building in and to preserve the site's natural areas, re-establish damaged native ecosystems, preserve the native plant and animal species, and make connections between the natural ecology of the site and natural systems, both within and beyond the site. This is the second step which we take into consideration. The third aspect will be reduce or eliminate disturbance to water system, minimize the water runoff, increase the site infiltration, use pervious surfaces, and celebrate these natural water management techniques by making them into attractive landscape elements like what we showed earlier. I'm sorry about it, there is a repetition of the figure. Install oil and water separators to treat the runoff from the parking lots. Lot of methodologies to capture the runoff water has to be taken into consideration. Design the roads and parking lots without curbs or with curbs cuts so that the water can easily flow into the drains. Now the next important step can be the prevent or reduce the use of potable water for irrigation. Rainwater harvesting comes into the picture. Use the recycled storm water or site treat, whether the grey or wastewater can be used for irrigation. Use water efficient plants. These are often native species or species that have adapted. Use water efficient irrigation, which includes micro irrigation, moisture sensors, weather controllers. Reduce urban heat islands, which we have talked in the previous session also. This happens by maximizing the green spaces through the use of native gardens, vertical gardens, roof gardens, everything. And we also can maximize the pervious surfaces, as we talked earlier, use light colored materials for non-pervious surfaces, etc. Now, one of the next consideration probably can be the building orientation itself. Use existing and proposed trees and plantings to reduce heating and plantings. These plantings can actually reduce the summer solar gain, channel summer breezes, and block the winter winds while still allowing daylighting. For example, let the winter sun through the shading, assess the feasibility of using on-site renewable or alternate energy, use existing and proposed topography to create thermal mass around the building. Then we also design for the flexibility, designs a structure that allows for changes in the use for some time. Also, this may include modular building materials, flexible floor plans with column spacing and floor-to-floor heights that can be easily adapted to many uses. And so modular construction becomes quite important. This also becomes one of the important parameters in our circular construction. Then design for disassembly, that is what I just talked about. Select the building systems so that it can be constructed at the end of life, buildings, useful life, and then we can actually start reusing the structures. So the next few steps could be configure the internal layout to reduce the loads and enhance the internal environmental quality and energy simulation. So by reduce the heating, cooling, and the ventilation loads through careful placing of internal uses, locate internal classes, all these things which are mentioned in the slides. I have put little more data into the slide because subsequently, if at all this doesn't get completed, one can go through the slides and actually try to understand the whole concept of what actually is the thing. We need to give importance and to locate the internal spaces to optimize natural ventilation, daylighting, and site resources like trees or the topography for shading, create operable windows where air quality is good and where prevailing winds will create desired internal pressures. All these things actually can be adopted. Use low VOC materials and use structures that do not require finishes that emit volatile organic compounds. Now, we also look into the designing envelope while optimizing the internal environmental quality. The envelope design becomes one of the paramount, takes paramount importance. And while designing the envelope to bring in the daylight and then use as much of the inhabited floor area as possible. Then design the envelope to provide adequate fresh air, which actually becomes extremely important. These two projects, what you actually are projected, and again, one of the projects, United Nations Environmental Project in Pondicherry, where I'm involved. It's a 4-bedroom, it's kind of a guest house, a community guest house, and each floor has got about 4 bedrooms. So we have 8-bedroom building what we see, and the total embodied energy what we could achieve is 2,800 megajoules per square meter. Whereas as I said earlier, the typical concrete, the typical building, even with the frame, it is not that the building what we see are entirely they do not contain RCC frame. Yes, there is a minimal RCC work which is involved. It is involved. So instead of 9,000 megajoules, it is reduced to 2,800 megajoules. So these, and instead of about 600 embodied carbon kg CO2 per kg, we could reduce it to bring down to 360 kg CO2 per kg. So these are this is one of the buildings. And then we also on the left-hand side, you see row of single floor buildings where the roofs are all vaulted roofs here with lot of air gap in between to the extent of about 1.25 meters at the crust, so that there is a free flow and everything is jolly. There are inlet pipes so that the fresh wind comes into the picture. There are no fans, no air conditioning units in Tamil Nadu. You can imagine the kind of, even then we could achieve actually an extremely comfortable indoor temperature. So this is another important aspect other than envelope, which actually leads to good indoor air quality, and good indoor air quality encompasses factors as maintenance of acceptable temperature that is good for the human comfort, and the relative humidity, control of the airborne contaminants, and adequate ventilation. All these things are actually required. The indoor air quality also talks about, the National Building Code also talks about the minimum requirement of window to floor area ratio, and there is a very detailed table is also given what exactly could be, especially about the fenestrations and the openings, the percentage of openings, what is comfortable to the human nature, and these things can actually come into the picture. And the next important thing is how do we install the water efficient systems? We already talked about it. Water closets which come into the picture, wastewater piping, the insulated into the alternative wastewater technologies. How do we can incorporate those things, and what methods and what strategies we adopt to reduce the ozone depletion, that is use of HVAC systems, refrigerants and fire suppressant equipment that do not contain CFCs and HCFCs. Now I think it has become a mandatory thing. Eventually HVAC systems contain CFCs or this thing are being phased out in due course of time. And all major building systems designs should be documented as at the time of commissioning. So this becomes an extremely important factor. Now, building envelope, which I talked about it, which becomes an extremely important aspect. And this building envelope configuration actually determines the amount of heat gain or loss into the building, and the extent of natural ventilation that comes into the building. The primary components of the building envelope which affect the performance of the building are the walls, the roofs, the floors, the fenestrations, the surface finishes, all those things. The envelope, it also imparts the thermal transmittance from the exposed roof, which should be kept at minimum under normal conditions. And under normal conditions, it is the desirable value would not exceed about 0.6 per meter square degree centigrade. So this actually is the one of the important criterias of building envelope which should be taken into consideration. Now, this is another a part of the community hall area which was shown earlier. This actually is a community hall where we could actually achieve again about 2,460 megajoules per square meter. Embodied carbon is around 302 kilograms CO2e. And we have actually run the cooling pipes in the flooring itself, so that the cold water through the is circulated, hot water gets completely goes out, and then there is a cool water which gets circulated, which actually maintains the temperature. Outside temperature is about 40 degrees, 45 degrees, and below this is approximately about 34, 35 degrees temperatures. And that is mainly because of the cooling and then because of the shape. And there are a lot of openings which actually allow the cool breeze to come into the picture. And what exactly now we come into the alternative. the alternative building materials which come into the picture. And before in the design, we need to take what exactly are the alternative building materials. So to say that ideal sustainable building material is not only environmental friendly, it causes no adverse impact on the health of occupants, is readily available, can be reclaimed, can be recycled, and is made from renewable raw material, but also uses predominantly renewable energy and its extraction in production, transportation, fixing, and ultimate disposal. Now, that's why it's very clearly said that I have said it is a ideal sustainable building material. It is impossible to get this kind of building materials, which becomes a utopian case. So what is important is we should have low body embodied energy materials to be considered, which we will show it I'll show you in the next slide. And then maximize the use of recycled and reusable content, preference to locally available materials and skills, rapidly renewable materials to be taken into consideration, material compliant with clean air, clean water, and those which emit a few or no carcinogens, material, toxicants, VOCs, etc., should be selected. So this is one of the important materials. Though it's impossible to get the ideal sustainable building materials, we should at least keep these things into consideration while designing a building. Now, most of the building materials are classified into very high embodied energy, high energy, medium energy, and low energy components. And this table, the greater embodied energy, with a value of greater than 50 megajoules per kg is considered as very, very high. For example, aluminium, stainless steel, plastic, copper, all these zinc, brass, everything, they come under a category of very high embodied energy. And very low energy, sand, for example, sand, aggregate, fly ash, stone, bamboo, these things come into low energy components. For example, walls constructed with rammed earth. There is an important concept also called the renaissance of the natural materials. We had earth construction is one of the oldest and most durable techniques for building structures which we have known, but it is slowly coming back into the picture. So we tried the rammed earth concept. On the right side, you see the rammed earth wall, the earthen concrete walls which we made use of. And what you're seeing is actually not the concrete walls, but it is the earthen concrete wall. And here is actually using the same earthen concrete walls, a vault roofed small 100 capacity conference hall was created, and you could see the construction there. And which also, this is a low carbon technique which uses forms in which the soil and binder is placed in layers and then pressure is applied to create a hard durable surface. We in fact even tried vibrating the surface. We literally used the plywood and the steel shuttering on complete material. So this is a new material which comes into the picture. Friends, I think I have come to the last part of this, and hopefully I have taken a little more time than what was expected. But however, the session topic is covered with these 12 to 14 important parameters which we have to keep in mind for a sustainable design. Now, what exactly is sustainable assessment? How do we assess embodied energy? How do we assess embodied carbon? And then where do we get those data? And what is important, becomes important is, other than water, there is no standalone material in the construction of a building which can be used. That means we can never use a single material without integrating it with the other materials. For example, cement, I can't use cement directly at all, though the cement has got extremely high embodied energy. We can't use aluminium, raw aluminium anywhere, or even simple extrusion cannot be simply used. They have to be made with used as a system. So when cement gets incorporated in concrete, what exactly, it is not the embodied energy of the cement comes into the picture, it is the embodied energy of the concrete matrix as a matrix comes into the picture. When we use aluminium extrusion as a material, the entire system where the aluminium extrusion gets, it may be a door, it may be a glazed window, partly glazed, partly paneled window, it may be a fully glazed door. All these things have to come into the picture. So we need to calculate embodied energy not of materials but of the entire matrix. For example, if you take waterproofing system on the terrace, we have embodied energy for bricks, we have embodied energy for cement, we have embodied energy for some other material, but how actually embodied energy, the entire matrix or entire system of waterproofing is calculated, this becomes the most critical area and critical phenomena of analyzing the sustainability of a building. And this is what the crux of the issue is. How do we analyze, how do we sustainability assessment can happen, can take place at the conceptual stage itself. So with these few minutes of presentation, friends, thank you so much. And for the information of the participants, the first talk has already been uploaded onto the slide share. I had passed on to the link, and most of the people also have got the links of the slide share. Otherwise, you can actually go and type on the Google the topic of the last session and my name, so that it will be on the top of the list, so you can actually get the search much faster. So with these things, back to you, Ranganath. If there are any questions, I can take it for a few minutes. Thank you very much.
Thank you very much, Dr. Ajit Sabnis. That was wonderfully presented presentation, which actually made us all think, and with the illustrations especially, it made things that much more clearer. And I'm sure all the participants who are there, they will have few questions. Before we go to that, Mr. Shrikant Chanal, do you have anything to share with the audience before we go to the question and answers, or should we go to the question and answers directly?
Yes, sir. I would like to tell a few points, if you permit.
Yeah, all the participants in the meanwhile can.
Thank you.
Yeah, so you can all regroup your thoughts and keep your questions ready, so that once Shrikant presents, probably we'll go on to the question and answers immediately. Mr. Shrikant.
Thank you, sir. From Bengaluru Center, we are our endeavor is to equip the civil engineers with all the latest knowledge and the tools that are required to become a good practicing civil engineer. In that aspect, our engineering series, and that we are getting.
You can unmute yourself, Shrikant. You can unmute yourself. Yeah.
Oh, sorry. Yeah. I think I have nothing has been heard from me.
Yeah. We heard. Go ahead.
Okay. Thank you. So after this series, we are planning to start another series on how a civil engineer who is born aspects is practicing and who is not at all till now not recognized by our statutory terms. With that regard, we are going to start some series later on about our professional issues, harming our profession. Then there are some techno-legal issues that are again harping our construction industry. Then there is an unprofessionalism or say quack, the issue that is very much prevalent in the industry. And then this bylaws, very ununiform bylaws prevailing all over the corporation bodies. When we compare with the NBC, in what way the NBC has to be adopted in the building bylaws and how to bring about uniformity in that. Then factors that are affecting the civil engineers outcome from the professional institutions, and how our syllabus has to be strengthened further. People are demanding, industry icons are demanding, civil engineers should be ready to be used. He is not ready or he is not fit for the industry, he should be made fit. That is also another demand that is there from the construction expertise, and that also we need to discuss. And similarly, there is an practice that is internationally and in India, what difference we have, why recognized everywhere, professionals are recognized, and such things are going to come up, and we are planning to take up those series also as soon as this series is completed. In that regards, we are preparing a lot of base for this. We are asking our fellow engineers to give us some kind of a technical articles, number one, and to give support to the ACCE headquarters that there is a task force that has been created to address the professional issues harping our professionals and the industry together. And we have many committees that have been formed. And please response to one of the Google response forms that we have already circulated, and we keep on circulating it. If anybody is not received, we will again recirculate it. You please respond through that. And if you join hands with us, that will be our strength, and we can achieve whatever that profession needs and what an engineer should have been. Back to you, sir.
Yeah, thank you, Mr. Shrikant. Now, any questions? One at a time. If you can just unmute yourself.
Google here.
Who?
Google.
Yeah, go ahead.
A very good presentation. Just want to know, these marks are awarded, in various rating systems, whether it is the lead system or the Griha system, for example.
Yeah.
For a particular criteria, the way they allocate the marks, let us say they have kept 10 marks for landscaping. I'm just taking a hypothetical.
Yeah.
And Griha, let us say, keeps 5 marks for landscaping.
Yeah.
Now, out of 10, how much I earn in lead system or in Griha system, I could not find any quantification. This appears to be a little subjective. Is there any parameter on which, very clear, transparent way they give the marks out of 10 or out of 5 for any particular criteria? I just wanted your opinion on this.
Yep. See, this is what you have said is this is one of the biggest drawbacks in the green rating systems. Now, we have different green rating systems. See, for example, the criterias are not exactly the same between any of the rating systems. And these rating systems, they have the rating systems, and then ultimately it is the professional, what they call it as associated professionals. They undergo very rigorous training to evaluate a particular criteria. Whether now it depends. There is no actually quantification of the criteria is not there at all. It is simply left to the professional who earns. So if two professionals evaluate the same building using the same green rating system, it may not be same. It's extremely unclear because there is no absolutely fixed criteria or the methodology to give the marks. And even the rating systems, some give gold, platinum, silver, etc. Some give star ratings. Some gives good, very good, bad, such kinds of ratings. All these things, at least I have compared between IGBC, LEEDs, and the other rating system. For example, Griha rating. For example, Griha rating, let us say, has got 86 and above, they will give you 5-star. Okay. And then, for example, IGBC rating between 80 and 100, if you get a score, then it's called a platinum. And if in case of LEED rating system, anything above 80 is a platinum rating. So this kind of variation in the criteria or the evaluation methods do happen in the green rating system. That is why I say to be more realistic, what actually important is with these green rating criterias which will lead us into the proper direction, we need to actually complement these criterias with some methodology, some algorithm that can actually quantify and then help us to tell that building, oh, look, your building is going to be, in the sense I'm talking, if it is evaluated at the conceptual stage, this building is going to be only 50% sustainable. Then we still have lot of opportunity to revise the material, to revise the what kind of methodology, what kind of technology can be adopted. Certain lot of flexibility available to reduce the carbon footprint. So I hope I have clarified.
This appears to be a major roadblock at this point of time.
Yes,
because this green rating is also being commercially exploited by the builders. So depending on where he feels that he can earn better points, he may switch to a particular system. It should not be like that. I mean, everyone should be able to get evaluated on same parameters. Anyway, I think going forward, we will come to this quantification more accurately. It is still subjective at this point of time.
Yeah, and one more important input for this is, actually there are a lot of suggestions. See, what happens is, I don't apply this to everybody, but there are certain builders who, as you rightly take, will take these kinds of ratings much before the project is completed, and then probably may not give much importance subsequent to the construction of the project. So how do we, once, let us say, a platinum rated building, will that remain as a platinum rated building throughout its design life, which actually is supposed to remain as a platinum rated building, and it should provide that kind of a human comfort to throughout the entire design life period. Whether it happens or it doesn't happen, we don't know. So there is a lot of now things that are coming into the picture. All the monitors are being installed into the buildings, whether the indoor air quality is still being maintained right, whether the concentration of oxygen is coming into the picture, whether the microclimate around the building has been affected. All these monitors are slowly coming into the picture. I don't know, God knows when it comes to India, but these kinds of things are already being talked about. So hopefully we will see these things not very far, maybe in the next 1 decade, we all should be able to be acquainted with these things.
Thank you, Ajit.
Thank you, Dr. Kalgal. Next.
Sir, excuse me.
Yeah.
Excuse me, sir.
Mr.
Yeah.
Devadatta Dubey.
Yes, sir.
Yeah,
so
please.
are there any standardized tables, etc., which can help us to compute the embodied energy? For example, if I look at a structure then can I estimate what is the embodied energy? Are there some standardized tables or something, or we have to?
Yeah, no. There are tables which are being updated very frequently. But unfortunately, as far as Indian context is concerned, there is no specific country rated inventory that is available. What I can tell you is there is one of the most updated inventory is called ICE inventory, which actually takes the global data across all the climatic conditions and then normalize the data and then publishes it. This is actually, you can look into the Google, it is easily downloadable also. It is called ICE inventory, which will give you the details of embodied energy and embodied carbon per kg of the material. But actually the skill falls in how do you take those individual embodied energy of the materials and then incorporate to the building systems and then individual matrices.
So the quantity surveyors actually would be able to do that once they get all the quantity required for the construction.
Yeah, once the bill of quantity is required,
Yes.
then it should be possible.
It should be simpler.
Yeah.
Okay. Thank you, sir. And sir, very rightly mentioned about those sensors, etc. So I've been reading some case studies about how they have ended up in saving energy costs and fuel costs. So that's really amazing. Using big data and artificial intelligence, they are able to generate substantial savings when they do the asset management and facilities management activities.
True. That is what it is, sustainability development. It doesn't mean that we go back to the old period, but we use all these modern data that is available, advanced data that's available to us, and then go ahead in future.
Yes, sir. Thank you very much, sir. Thank you.
Thank you.
Sir.
Thank you, Mr. Dubey.
Can I ask you one question, sir? I am Dr. Jagannath Rao. Sir.
Please go ahead.
Yeah, please go ahead.
Sir, leave aside the different rating systems, sir. Even if you take a single rating system also, as you have rightly mentioned, if two evaluators do the evaluation, they may get different ratings you have mentioned, sir. So are there any efforts by IGBC or any other organization putting in to solve such problems or quantify certain parameters, sir?
Sir, it is like this. In a class, the syllabus is same, the teaching is same, then why an individual student some students get good marks, some students don't get good marks. Okay, it's exactly the same thing. As an organization, IGBC has established excellent criteria. When you go through this, whether it is TERI or it is IGBC or any green rating system criteria, if you take, there are a lot of efforts, genuine effort put behind that. And these, how good a professional who comes to rate these buildings or evaluate the building, how good he is at understanding those criteria. It all comes to that. So they can't be at the same level. If they are at a different understanding level, then their rating using the same rating system is of the same building is bound to be different.
So there's no ambiguity in that, but because the interpretation it is happening, sir.
Exactly. It is the interpretation which comes into the picture. Unless we adopt a method which actually gives us the figures in terms of which actually quantifies, which I'm going to talk in the next few sessions. And I did not elaborately touch upon water conservation and alternative materials, because the next two sessions, Dr. Rajkumar and Engineer Rajkumar and Engineer Kalbavi are going to touch upon these two issues extensively, and that is why elaborate discussion on materials and water was left intentionally.
Okay, thank you. Dr. Sundar Kumar. Dr. Sundar Kumar, you have a question? Yeah. Anyone else? Any other questions? You can raise it. Mr. Basuraj, please go ahead.
Sir, good evening, sir. Sir, good evening, sir. Sir, I have actually question. See, while doing all these things, is there any analysis made so regarding like time overrun, cost overrun, and how best we can achieve this system in urban like mud blocks or see other technologies what you explained in your slides? Can you just put light on it?
No, see, in urban scenario, it's definitely not possible to use some of the old technologies what I showed. There, RCC as one of the versatile materials which has to come into the picture, because we are talking about multi-story buildings. We also have to talk about several other important criteria. But when we do take up that into consideration, how exactly see the minimum embodied energy for a earthen building or earthen architecture building may not be same as for the concrete framed structure. So what needs to be done is, for example, I showed you the building of Antilia, which has got 9,000 megajoules per square meter. Okay, instead of that, 9,000 megajoules per square meter can be definitely brought down to 4,000 megajoules per square meter, which actually may be the benchmark value for the RCC framed work can be about 3,500 to 4,000 megajoules per square meter of the building.
Yeah.
So this is how it becomes. And also what becomes important is what kind of, in a commercial building, what kind of building is it? What kind of activity is it undergoing? In fact, every building, every human being, even as a human beings, we all generate heat, correct? I mean, we don't give importance to it. Where does the heat generated by a human being goes? Where does it go? See, we have a metabolism. Whatever food we intake, it gets digested. There is metabolism activity which generates heat. There is a building up of tissues which generate heat. All these things, and then we still have to maintain for a good health 37 degrees centigrade. The excess heat which gets generated, gets converted and then gets passed through the process of convection, because there is a skin and then there is a shirt or the cloth which we wear, and then that acts as a media to convert transfer the heat. So the number of inhabitants that stay in the building, what kind of activity that industrial or the commercial building taking place, all these things have to be traded off against when we calculate the true quantity of sustainability. Only, it looks easy. It looks like the previous one of the participants said, it becomes extremely easy for the surveyor, quantity surveyor, to analyze the building. It becomes easy to understand, but what actually is, how do you do the trade-off, and then how do you interpret those buildings, taking all these things into consideration? That is where the skill and then the professionalism and the expertise lies.
I have a small.
Thank you, sir.
Can I have?
Thank you, sir.
Ravindranath Kundatla.
Good evening, Dr. Sabnis. Congratulate you. Very nice presentation.
Yeah, thank you.
See, I just wanted to ask you one thing. Can two buildings having same EE have a same rating or vice versa too?
As far as the embodied energy of the same building, if you are calculating using the same methodology, should remain same. But this will not happen with the green rating system. As already, if two different persons, two different professionals use the same rating system, then also it should differ, and two professionals using different rating systems, then also it will differ. The only possibility is if the same professional does the same, both the buildings having same embodied energy and uses one single rating system, then there is a possibility that the figures match. Otherwise, I don't see any probability of these things matching.
Thank you. Another second one, Do you have any software tools now to calculate the embodied energy as of now?
No, there are a lot of calculators which are ready-made calculators which have come now. There is one software which is called Edge. You need to feed in a lot of data, which is extremely user-friendly, and then a lot of people are using it, a lot of architects are using it, and then there are a lot of professionals, so-called people who analyze. They use some of the softwares like this and then put their seal and then give it also. But actually what happens is in all these things, you don't get actual figures. What happens is, for example, I will go back to the example of waterproofing system. Now, let us say if the waterproofing system, if you have used a combination of, let us say you do the water brickbat Coba, and then there is an additional layer of screed, and let us say it fails, and then you do one more coat of some kind of a membrane coating on top of it, and then you again protect it with a screed. Now, what is the embodied energy of this whole entire matrix? Now, you need to calculate the embodied energy for this complete matrix which has come into picture, and then come the overall embodied energy per square meter. But if you take only the embodied energy of the membrane per square meter, then it doesn't help you. But only the screed, it doesn't help. So in case of wooden windows, let us say, nobody goes in for wooden windows, but let us say there are doors and windows. Now, if you take door, for example, there is a wooden door, there is polish, there is external polish, there is internal polish, and then there is ironmongery, or there is brassmongery, or there is steelmongery. All the embodied energy of these things have to be put into place and then give it. But the general calculators which are available on online do not go into so much of detail. The normalizing or the normalization is on a very, very superficial level. So it should not be actually taken for granted.
Thank you. I think a holistic approach is what it's
exactly. Yes. An all-inclusive approach is which we are going to talk in future. The next few sessions, it's going to be that.
Thank you. Thank you, Doctor.
Thank you,
Mr. Ravindra. Next question, please.
Sir, I have a small question. I have a small question.
Yeah, please.
We understood some of the basics of this embodied energy and carbon footprint in the buildings. I would like, I was having a curiosity that maybe of the if any comparison is these parameters. Question one. Question number two.
No, I need to hear you.
This knowledge is in our ACCE.
Srikanth, sorry, can you kindly repeat? I didn't hear anything.
Sir.
I didn't hear anything. Can you repeat the question?
Can you hear me, sir?
Now I can hear you. Speak a little slowly on the mic. Audible to you? Yeah.
Okay, sir. See, these parameters which beautifully you have shown for that Mukesh Ambani building in Bombay, that was very interesting to see the things. I wanted to know whether a single story, two story, it goes on increasing, our number of floors goes on increasing. What happens to the sustainability criteria? Whether it comes down or whether it will increase? Because nowadays high-rise is the order of the day. This is one part of my question. Yeah. The other part is why from our ACC being such a knowledgeable person like you, we are not considering, green building awards to the buildings, because so many awards we are giving it to the outside, but we are not considering this green or sustainability building award at all from ACC. Why don't we do that? What do you say is your opinion? Yes, sir.
Yeah, I will take the second question first. I think if I think everybody is listening here. Most of the governing council members are also here. I don't mind. It's a good idea actually to consider giving green building awards from ACC. I think it can be evaluated. Evaluation procedures, criteria can be developed, and in fact, Shrikant, ACC has got a vision document which was prepared in 2015. I had suggested this thing in that document, which since we are a part of the team now, you can go through that ACC Vision 2025, which was prepared in 2015. And all these things actually are there. Only things is we need to implement these things. And then as far as coming to your first question, you should go back to my first session and then understand how do we define sustainability. It really doesn't. So the most important criteria is the sustainability aspects are more critical in the urban scenario and where high-rise buildings are there. Yes, it does matter, and that is why what happens is if you have understood the embodied energy and then embodied carbon, and when we take these things into consideration and then do the life cycle analysis, what actually omission here is the cost of construction. The cost stimulants are not included at all. For example, a high-rise building of 3 floors versus 30 floors, the cost of building, cost of construction per square meter may be different, right? And the properties, the engineering properties of the materials that are used in a 3-storied building and 30-storied building are different. Probably the density of the materials may be different. The wall configurations may be different. The roof slabs may be different. Now, for example, one of the ACC members has come out with a beautiful structural analogy, which where the high-rise buildings take into consideration and then sustainability is taken into consideration. Now, what is important is the embodied energy part of it, or embodied carbon, or life cycle analysis as we are doing it, do not take into consideration the cost stimulants, for example, the cost of the building, cost of construction, and the engineering properties which play a critical role for civil engineer while designing the building are not taken into consideration. And those are the biggest limitations with the present kind of analysis which is happening. What we are going to discuss in the next few sessions, what I'm going to talk about sustainability development indices. All these things those indices, those will consider even the cost stimulants into consideration, cost of construction into consideration, and the properties of the materials into consideration, and also take embodied energy, embodied carbon, and several other eco parameters into consideration. What exactly is the transportation coefficient? What exactly is some other coefficient? We design the life for about 60 years or 40 years. Whether the design life of the building itself has any impact on the sustainability assessment. All these things have to be taken into consideration and then assess whether it is a multi-storied building or a high-rise building, it should taken. But as I say, I don't see much of a sustainability variation in the sustainability assessment, whether it is a high-rise building. For example, high-rise building, we can put all high-rise buildings into one category. Let us say that is from 5-story building to 15-story or 30-story buildings, which are very common nowadays. We can put them into one category. As I said, only iconic structures, super tall structures, all those things cannot come into this consideration.
Yeah, thank you. Thank you, Mr. Shrikant, for the question. Friends, that was, I think we have taken more than half an hour more than the scheduled time. But anyway, it was very interesting. And what I would suggest is all of you who have questions, you can please send it by email to the association's email address. And we will definitely take up those questions, discuss with Dr. Ajit Sabnis, and come back to you with the answers. I think that would definitely help everyone to raise their questions. With that, I think we'll be closing today's presentation. I request Engineer Shrikant Chanal, Secretary of the ACCI Bengaluru Center, to propose a vote of thanks. Mr. Shrikant, you can unmute yourself.
It was a wonderful second lecture from Dr. Ajit. We have today we learned lots of technical parameters, new things, and I hope all the members are benefited a lot. I was in chat. Please share the PPT, share the. I think most of them runs. Yeah.
Shrikant, we can't hear. Shrikant, you have to unmute yourself. You are unmuted.
I don't know why it is very often getting unmuted.
Yeah.
Okay.
In fact, you are unmuted. Still, you are not. We are not able to hear you. Yeah, please go ahead. I'm sorry.
Yes, sir. So I thank everyone for the participation and hope all the members whoever have participated will get benefit out of all this thing. And as I said in my earlier welcome address, we should be equipped with the sustainability tools to survive in the field. Otherwise, we will be handicapped, what we can say, because that is the order of the day today. Other professionals and other things, they are very much eager to catch the things, and if we lag behind, means totally will be behind the scene and will become the second grade professionals. So in that aspect, this series was started, and hope everybody is getting benefit out of it. Thank you, one and all. Thank you, Dr. Ajit Sabnis, sir. Thank you, Moderator D. Rangnath, sir. And thank you, one and all. Have a nice day. Be safe. Good night.
Yeah, thank you all the participants. Thank you, Shrikant. Thank you, Ranganath. And thank you once again, all the participants. See you next week. Thank you.
See you next.
Thank you. Fantastic show. Thank you.
Thank you.
So we'll close now, sir.
Yeah, we'll end the session. I'll end it.